the angle, right? That's the direction you're supposed to head it. So pi 4/3 means go to 180 degrees and go 1 1/3 units that way. The only time you ever deal with negatives, what a negative does is, like 0, -4, negative means turn around, or the way that Stephen and Adina figured it out was at 180 degrees, I think.
Yeah.
On that day. So this means face in the 0 degree direction, but then the -4 means go in the opposite direction 4 units. But pi 4/3 is right there. That is supposed to be positive because we're facing in the 180 degree direction when we start. I hope that makes some sense.
That makes sense.
That made no sense.
Yeah, I forgot we were.
Right. You want to talk blue? Yeah, and when you said it, you sent me right back to Cartesian coordinates and got me confused. Okay.
We're good now.
Now, these 2 points here, I wanted to do these anyway, pi over 2 and 3 pi over 2 being 4, equaling 4, because they, and notice, Lauren, they're both positive 4. This means 90 degrees, go up 4, 3 pi over 2, go 4 units away from the origin. This is how you get some idea of the curvature of the hyperbola.
How? Okay.
Because when we fill in these points, we know that the hyperbola has to hit these 2 points. And now, over here, I will just trust you guys to make it look as symmetrical as you can for now. And I'll let you know on the test if I want you to find any more points.
Why not just make 4 and 4?
Well, what you'd have to do to make it symmetrical, you can, but here's where they'd be. Okay, from here, this 4 and this 4 are both above this focus, and this focus is 1 1/3 units.
Yeah, okay.
So we'd have to go out to 5 and 1/3, and then up 4 and down 4 from there.
Just kidding.
So for symmetry, we do know that the points in the rectangular form are -5 1/3 on the x-axis, 4 up and 4 down. Don't even ask me to convert that to polar and tell you what angle of distance these are.
Wait,
You had it right when you were thinking mirror image. Okay? So that's how you graph one of these. You always want to make this table. Always, always, always want to make this table. Even if it's a parabola or an ellipse. Okay, yes?
Hey, I'm confused.
Yeah.
Because it says when the thing is minus or whatever,
Yeah.
the second focus is further right.
When it's minus, I should have written second focus
Yeah, well, you
is further plus the second focus. Apparently I have that backwards. Is this what I wrote for a hyperbola?
Yeah, you wrote for the second focus is further left.
I wrote this backwards. This is a great lesson.
I don't like
minus is
I'd rather be a
second focus
chopper.
is further right.
Plus further left,
that's what you
minus further right. This is right for an ellipse.
And the parabola.
We're doing a hyperbola.
The hyperbola, the wings go.
So for the hyperbola, yeah, if this is minus, so your other focus should be further
What are you talking about?
left. Yeah, that's what we got, right?
5 more minutes, time for break.
No break.
No, you said it right.
5 minutes.
Never break. Okay.
You have it written down as what?
Right.
When it's minus,
Wait.
it's further right.
Why? What's
So,
up with the dotted
that's-
It's
line?
minus and it's over here. That's the directrix.
But that's left.
What the hell is that?
Yeah, this is further to the
I know
left,
what it is, but
this
like, where do you
focus.
get it?
And the thing is minus.
It's from
the-
E.
Are you sure you did that
So
right
it
with the
doesn't make
-4?
sense.
Yes.
Just go onto YouTube.
If it's minus and the second focus is supposed to be farther right.
I must have said that backwards then. Or, yeah, it must have been either wrote it backwards, said it backwards, or you wrote it backwards. Probably me.
Wait, what?
Because these
So
points
it's
are correct.
further left. So it's intuitive. When it's minus, it goes further to
For
the
the
left.
hyperbola it is. Yeah, let's do an ellipse and see what else we can figure out.
I don't like you.
Yes.
Carl.
Mr. Gillis, yes.
Mr.
Dotted line.
Directrix.
I know that, but where did we get directions from?
P.
Just P.
Yeah.
So we just go P over from the origin.
Yeah. In this case, left, because it was minus, which is intuitive.
What?
So it's only
Repeat that
intuitive for a hyperbola.
So at this point, the only thing I would trust is this table. You know what I mean? Now I'm sure we're doing right.
So
I'm just gonna
Yes.
are we using those points every single time?
Yeah. An ellipse definitely. It'll probably be a little confusing. I want to do an ellipse really quickly.
No.
What's up?
Hold on, so an ellipse is different?
Yeah.
So you don't use those numbers?
Yeah, you know, use those numbers. Okay, R equals. Ready, new example. This will be an ellipse, and the numbers will be ugly. 12 over 5 plus 3 cosine theta. Only thing I'm going to say for certain is it's going to be horizontal.
Wait, it doesn't work.
It works, it'll just be ugly.
No, you can't pull it out.
Yeah, you can.
So then this means that
Some ugly numbers.
So what we're going to have is 5 times 1 plus 3/5 cosine theta, right?
I'm just gonna.
Correct?
Oh, I'm
Sure.
Okay.
Yes.
Now this means eccentricity less than 1.
Why do you?
So what are we talking about?
Where's the
Why
5?
do you
Or the
need-
5 is still there. It doesn't work.
This one will take care of it. See, now I'm going to write it like this, Adina.
Huh?
why?
I hate you.
Is this the transition pattern?
That doesn't even work. What the hell?
Yeah, that's the same thing as what we have below.
No.
Multiply top and bottom by 5.
You
It's
can
not.
do that. That's what I do all the time because
Yeah.
I don't like turning things into.
This
decimals.
works.
I hate you.
You're allowed. Now, eccentricity less than 1 is a...
Oh,
3.5.
parabola,
No, it's equal to 1.
ellipse.
Ellipse. Very good. It was the only thing left. Okay? So E equals 3/5. Now, given that this is EP,
Close.
if EP is 12/5, then yes, P must equal 4, because 4 times 3/5 would get us 12/5.
What do we grab?
Is it negative
Oh,
3/5?
You know,
Wait, is it negative 3/5?
I don't think so, but double check me.
Wait,
What did it say?
wait, then why was on that one it was
Don't
2,
press it
negative
yet.
2 when it was a minus though?
Because I've sucked it, because it was a different problem to start with.
I know, but like that one when we
Like,
did
you know
it,
what?
it was
But
a-
here's what I'm
it
going to do
was-
first.
Look. the
Connor,
thing
hang
was
on.
negative.
Okay.
Hang on, we're moving on now.
That's because
Stop living in the past.
That direction. That's
move
plus
on to
minus
the
has to do with
future.
direction, not the actual thing.
Now, guys, as long as you're careful here, here's what I honestly think I'm going to do to help me. I'm going to start by making the table every time. Because if I get these 4 points, it should really help me make sure I get the rest of the shape right.
X and Y.
Wow, thank you, Stephen.
Maybe that's why we graph it like X and Y, because you tell us to.
Theta R stop.
You just
Stop.
had me write that.
Okay, now 12 over 5 plus. What's the cosine of 0?
0.
Cosine of 0?
1.
1. 3 times 1,
8 over
12 eighths. Okay? 12. Now, 12 over 5 plus 3 times 0 is 12/5, right?
Yep.
At pi, we've got the negative 1,
Wait.
correct? So 12 over 5 minus 3 is 12 over 2. This should be 6. Double check me, is that correct?
The next one is 12 over 5.
Next one is also 12 over 5, and at 2 pi it should be 12 eighths again. So we've got at 0,
Bus
12
checkers, please come
eighths
to the front
is
section. Bus checkers to the
1
front
and a third.
section, please.
12/5 is a little over 2, right?
The homework is online, right?
Yeah, homework's online. And from these points, this is the point where you're sure now. 1, 2, 3, 4, 5, 6. Hang on a second, Dina.
I know, I'm not leaving.
You can see now, as badly drawn as it is,
It looks like a heart.
that this is an ellipse going to more to the left.
Nicely done.
Okay, thank you, yes. And you can, and from here you can also find the directrix, because P is, what did we say, 4? So the directrix is over here.
The bus leaves relatively quickly.
Yes. When in doubt, use the 4 points. Good luck on the homework tonight.